Well, welcome back to the channel. Hope everybody's doing well. And in today's video we are taking a look at the CA8220 from Chauvin Arnoux. This is a power analyzer for single phase and also balanced three phase, primarily aimed at testing motors, which is the reason why I've purchased this. But this purchase is second hand. It's from eBay, and this is all that has come to me. I've got the meter here, obviously. We have one current clamp. I have a communications lead that fits into the side port there of the meter, and then I have another set of leads here, which is just crocodile clips. However, I don't believe that they are the original Chauvin Arnoux leads. With that, it's all come in this little suitcase kind of case here, which is okay, but I think I will be getting rid of that and moving it into probably some Milwaukee pack out along with the Chauvin Arnoux insulation tester I've got. So we'll get it out of this case and we'll take a closer look at it. So from what I can make out from the literature, if you buy this instrument brand new, you get the instrument, comms lead, you get a set of Chauvin Arnoux leads with their crocodile clips and silicon insulated leads and a set of probes. These actual leads and crop clips are from my insulation tester. I believe they are the ones that will arrive with this instrument, not these ones here that came with mine, because these are actually labelled MC, so I believe these are multi-contact third-party set of leads, which occasionally happens with instruments, of course. I do not know if you get a calibration certificate with it. You may well do. Second-hand unit, I didn't get one with this. You do get software as well, but you have to download that from the internet, and you can also download the manual from the internet as well. And that is all you get for your money. Your money being, in the UK currently, cheapest I can find this is £860. RS Components have it on stock for £970, which is generally, RS Components are closer to the recommended retail price, so I presume that's his RRP, and the £860 is from Tester. So that's what you get for your money. That enables you to measure the voltage and the harmonics. If you want to start measuring current, so you can use the power then, functionality of the instrument, you have to buy a current clamp which is separately. So the one that came with mine is the MN93A. This is an adjustable 100 amp and 5 amp rating, and on test meter that was £322. Now other clamps are available, so this may not be the cheapest clamp. There may be other ones out there, and there are obviously clamps with a higher current rating. However, I believe you are stuck with using a current clamp from Chauvin Arnoux because of this connector here that goes into the top of the instrument. This isn't compatible with another manufacturer with standard 4mm jacks, so you are stuck to using a clamp from Chauvin Arnoux. So I believe when you purchase this new, you also don't get a case with it. The case that Chauvin Arnoux recommend as an accessory is this one here, carry bag here, which the instrument sits on the top like that, and then you can get access to the connections and connection port there as well. However, they do remain all open. There's nothing to cover them up when it's in storage, just to make you aware of that. And then you have the accessories that can sit in this pouch beyond, and you can also use these leads to clip up to the harness to make it a neck hanging harness, so you can hang the meter from your neck and utilise it like that. So it's a fairly flexible bag. However, I did find this on RS Components, retailing for £110. So that's quite expensive for what you get here, really, just for a partial bag. So I kind of understand why the previous owner went down a third-party case route, really. It's quite a cost. So we'll slide all the leads out of the way and we'll take a look at the instrument itself. So I thought I'd just look at some of the functionality of the instrument whilst we're injecting some volts and some amps. We've got the SMRT one from Mega injecting 230 volts and 1 amp at this moment in time. I've just got the current clamp on the feed-in wire to the clamp table at this moment in time, and we are reading 230.1 volts and 1.0 amps and 50 hertz, which is all pretty good. What have we got? Voltage wise, we are 6 volts to 600 volts RMS. Same range on DC as well, at 0.5% plus 2 counts, so that's well within spec. Current wise, we are AC current 100 milliamp to 6500 amps at 0.5% plus 1 digit. DC current is 100 milliamps to 1700 amps at 1% plus 1 digit as well. Obviously that is split across the current clamp that you have there. I will just zoom into the screen so you can see a little bit better. Those are the readings that I'm getting. And we are actually, the clamp is set up to 100 amp range, so I'll just flip that to the 5 amp range. But it doesn't improve the resolution, unfortunately. So that seems to be irrespective for that particular clamp, which is a shame. I'd have liked, especially at 5 amps, I'd have liked a bit more resolution on the current reading there. Unless there's a firmware upgrade that would help with that, I don't know. Whilst we're zoomed in here, our arrow keys here, select the page that we're on, so we're currently on page 1. We can go through to page 2, and we've got our RMS, our DC measurement, which is 0, and our crest factor 1.41, which is smack on. Next screen, third screen, gives me the maximum, the average, and the minimum there, and then we get our peak values there. Okay, so that's the first function on there. All the positions on the function switch you see around here are dual functionality apart from the RPM. So the initial one we're on is volts and amps. To select between the functions, we've got the white key and the yellow key here. So I've hit the yellow key, then move to the amps, and zoom back in. So you get our voltage there, but we've got amps at the top, and we switch to amps on the screen there. And we go through the screens again. We've got 1 amp, and what we'll just do is I'll put the clamp onto the 10-turn coil. And we're out of range because we're on the 5 amp range. So we'll set that to 100, and we get 10.0 amps, crest factor 1.42, all good. Maximum is 20.3 amps, 10 amps, that must be, so over range function it went. Minimum is 0. And then we get the peak values there, and we've got this KF value. I'm not sure what the KF value is, it's some sort of factor involved as well. I need to read up on that a little bit more. That's the screens there. You can scroll around, you can move between the screens, but you can scroll when you get to the end. So again, it takes it back to screen 1. So we have all that functionality. Putting back on voltage on the white button, 100 volts, 10 amps, that's all good. Going on to the next function switch, this is power. So you can have power either 3-phase or single phase. It defaults to single phase. To get to 3-phase power, we go onto the yellow button, and then we select it there, on or off. Obviously I've only got single phase injection test set, so that's all we can do at the moment. We've got 1 kilowatt displaying, which is 100 volts times 10 amps, and that matches our KVA, and our KVAR is 0. So if we go to our current, and I will put in minus 30 degrees. So minus 30 degrees power factor is around about 0.86, so we're now showing 867 kilowatts, 501 VARs, and we've got 1 kVA, so the kVA stayed the same, but our kilowatts and kVA have changed, which about matches, so that looks all good as well. And rest of the screens, we've got 12 screens on this, so we've got, there's our power factor screen there, DC power as well, which we're not testing at the moment. That then moves on to some energy consumption measurements. I believe I have to set these up from the setup menu, which I haven't done yet, so these are all just going to read 0 at the moment. So we've got an overall watt screen there, and then our actual wattage load, our reactive load, VA, And then supply, what else supplied? Reactive supplied, and VA supplied. So that functionality is all built into the instrument as well. As I say, I haven't played with that yet, so that's a to-do list. The third function is harmonics, and again this is split between a voltage function and an amperage function. Currently we're reading 100 volts. Our THD, total harmonic distortion, is 0%. Shows you how good this test set is, I guess. We've got 52 screens on this because this can read up to the 50th harmonic. So we then have our DC harmonic, which is virtually zilch, and then our harmonic number 1, which is our fundamental 50 Hz, is 100%, and everything else will be on 0 on this. I have to hook it up to something else to pick up. That's interesting. Got a slight harmonic, 7th harmonic there. So we've got some odds. Yeah, odd harmonics, very, very small values. So that's there. We can also do that with the current, exactly the same. Let's return back to the screen, original screen. We've got 10 amps going in, and total harmonic distortion is 0.4%, so a bit more distortion on the amperage. And we can move through them. And again, there's our harmonic 1, which is 100%. We've got, yeah, looks like we've got slight odd harmonics it's picking up. Little bits. Yeah, okay, so all of those values are in there as well. Our next function we need to go to is our startup, which I will need to change the program on the injection test set, so just bear with me whilst I do that, and we can have a look to see how well that works. Okay, so we've set up our program. Our Inrush program is set to supply 80 amps Inrush over 115 milliseconds. We switch to ready. What I'm just going to do, if we just boom out, down here there's a setup function here. So on our setup, we set up our starting current, that it initializes it. That's quite unusual. The vast majority of the current clamps, in fact all the current clamps that I have that have an Inrush function, you can't set the threshold, but you can on this instrument, which is an advantage. So you set that up using the yellow and white buttons there. I've got that set to 30 amps, and then on the next screen is our hysteresis for how it sits between the steady state current and the Inrush current. So those are the two settings that you need to set up, or you can adjust and play with whilst you're doing this instrument. I believe it's in percentage as well, yeah, so it's fixed values, 1, 2, 5 or 10%. Leave that on 5, see what happens. So then going back to our actual function there, we can zoom in a little bit. So we're on the actual Inrush function. It sits to ready. What you're going to have to do is initialize it. So now it's sitting ready to record data. If I run the program, go there. So there you can see my 80 amp Inrush current. It's picked it up. 80 amps RMS, which is equivalent to 113.6 amps peak and 0.135 seconds, and that's all the data that you get with that. If you want to repeat the measurement, you just hit the 2 arrows and we can go again. So 50 amps I'd set it to, and it's come out to 50.6. Again, the peak will be 1.4 times, I guess. So yeah, that all seems quite good. The second function off of this switch is phase rotation, which you get to on the yellow. So you just measure the L1 and then the L2, and it should give you the phase rotation. Obviously I can't demo that, it's only a single phase injection test set, so that will not work. We then next move to RPM. Again, I can't do this because it needs the probe. As I said, I did have a look for the probe. Can't find that anywhere at the moment in time, so I'll have to inquire about that, see if I can get hold of one. And then we'll move to temperature and resistance. So I can knock this out of the way and I can get one of the little calibrators up and we can measure the temperature, because that is a PT100. So we should be able to simulate that alright. So we'll have to have another pause whilst we set some of the test equipment up. So we've got our Mr. Signal unit plugged in here Temperature wise, we display both degrees C and degrees F at the same time by the looks of things. We can measure from minus 200 to 850 degrees C at 1% plus 10 digits. So we've got our Mr. Signal there, and if we go, there's minus 200, as good as it can get. Let's go on, and minus 199.8. That's not bad, is it? Oh, don't know why we're flashing. Okay, 99.7. Seem to have settled now. There's our 0. That's pretty good. Let's go all the way up to 800. 801.800.9. Yeah, that's all pretty good there. So we've got that functionality as well, which obviously if you're testing motors, you want to know the temperature of the motor. And a lot of motors, even if you're offline, they do have PT100 sensors in them sometimes, so you've got the functionality to measure that there. And our final one is resistance, which is off of the yellow button on here, and we are measuring 376 ohms. Wouldn't have a clue. Let's go down to 0 there, because that will be 100 ohms. And we've got 100.2 there. That's all looking pretty good. Resistance wise, we are 0 ohms up to 2 kilo ohms or 2000 ohms at 0.5%, but plus 2 ohms, 2 counts, so that's not brilliant, is it? And even if we go lower, what happens if we so we've got a continuity below 20 ohms. Oh, that's the lowest I can go. Let's change our output to ohms. So we're now on 0 ohms. We're reading 1.2 ohms, but we've got no resolution there really. For motor winding resistance, that's quite poor. 10 ohms. There's 20 ohms, so you've gone off there. So it's reasonably accurate, but we've gone into low battery now. So the buzzer takes a bit of current from it. So that's the resistance functionality there, and the temperature functionality. So they're all pretty good, and that's the majority of the functionality I can demonstrate at this moment in time. So that's most of our functionality covered off with regard to these buttons on the right here. They're for selecting and setting up functions. This 4 here are for data control really. Have to be quick, the battery's going low, so we can just press the steady state there, and we take a snapshot there. So this takes a screenshot if you like. Quick set to that. It works on that. It does work on power as well. It does work on harmonics. Sure, let's just trigger that again and just see whether it snapshots. Okay, so you can't take a snapshot of the current setting. It's 3-phase. That's it doesn't like that, does it? RPM you can't do either. The temperature, resistance. Okay, so it looks like you can just take screenshots of the 3 functions for the voltage, amps, power and harmonics, and then the other remaining 3 functions you can't take screenshots of. So that's a little bit of a limitation there. To get to the readings back afterwards, you've got the storage file button here, and then you can work your way through them. Don't know whether you can actually display them. I don't think you can. You'll have to read up as to whether you can actually display them or whether this is just a function to delete them. That deletes the number 3 there. So go straight to number 4. So yeah, I don't think you can call them back on screen. Not found out how to do that. That's just for you to download into the computer software, which would probably be another video by now, I would imagine. But there you go, that's a little review of the CA8220. So I've purchased it for playing about with motors and to see if I can utilise it with AC impedance testing. It looks like it's only really 50-60 Hz, so that limits some of the work, and also the resolution of the current clamp isn't brilliant for me for that aspect. So I'll see if there's a firmware upgrade that will give the current a little bit higher resolution, which I would need for that really. But other than that, fairly happy with that instrument. It'll be something else to play around with to see what else it can do. That'll be it for this video. Thanks very much for watching. Hope you found it useful, and I'll see you again in the next one.